Welcome to session 4. In this session, we are going to discuss about introduction to weathering, mechanical weathering, chemical weathering, biological weathering, and weathering effects on civil engineering projects. So first coming to rock weathering. Weathering is a process that causes the breakdown of rocks either to form new mineral that are stable on the surface of the earth or to break the rocks down into smaller particles or smaller fragments. Weathering is the result of the interactions of air, water, and temperature on exposed rock surfaces and prepares the rock for erosion. Erosion is the movement of all the particles by ice, wind, or water. The particles are then transported by that agent until they are deposited to form sedimentary deposits, which can be later eroded again or transformed into sedimentary rocks. Weathering is generally a long and slow process that is continuously active at the Earth's surface. So there are three kinds of weathering. They are mechanical weathering, chemical weathering, and biological weathering. So first coming to mechanical weathering. So mechanical weathering is also called as physical weathering. It is the process by which rocks are broken down into smaller particles or smaller fragments by the external condition without change in the composition. That is called as mechanical weathering. The process involved in the mechanical weathering are as follows: a single block is broken gradually into numerous smaller irregular fragments and then into smaller fragments. Further, it is classified into block disintegration and granular disintegration. When come to block disintegration, this is because of the regular arrangement of atoms in a rock. Due to this, individual blocks are obtained. When come to granular disintegration, this is because of irregular arrangement of atoms in a rock. Due to this, small grains are obtained. So next is frost action. When rainwater is trapped in joints, cracks, or pores or fracture, then the water freezes and expands during low temperature. That means during night time, and this will gradually lead to partially or total disintegration of the rock into smaller pieces, forming a angular or subangular fragments. So next one is thermal or heat effect. The effect of heat, change of temperature on rock, is of considerable importance in arid and semi-arid regions where difference between daytime and nighttime temperature is very high. So temperature variation in season also, in summer season and also in winter and rainy season also. Expansion on heating followed by contraction on cooling. Repeated expansion and contraction of the same rock body gradually breaks into smaller pieces due to stress developing by this process. So next one is spheroidal weathering. It is the combination of mechanical and chemical weathering process due to which the rounded boulders are produced in the rock. Water can penetrate more easily along 3D network of joints and fractures. These joints and fractures are weathered inwards to form cube-like pieces. The rate of weathering will be greatest along the corners of the each cube, followed by the edges and finally the faces of the cubes. As a result, the cube will weather into a spheroidal or spherical shape with unweathered portion at the center and weathered rock in the periphery or corner referred as spheroidal weathering. Next coming to chemical weathering. So it is a process where chemical alteration or decomposition of rocks and minerals takes place due to rain, water and other atmospheric agents. Chemical weathering weakens the bonds in rocks and makes them more vulnerable to decomposition and erosion. The process involved in the chemical weathering are as follows. The main agent responsible for chemical weathering reactions is water, oxygen, and weak acids. These reacts with surface of rocks to form new minerals that are stable in or in equilibrium with the physical and chemical conditions present at the Earth's surface. Any excess ion left over from the chemical reaction are carried away in the acidic water. For example, feldspar minerals will weather to clay minerals by releasing silica, potassium, hydrogen, sodium, and calcium. These elements remain in solution and are commonly found in surface water and groundwater. Newly deposited sediments are often cemented by calcite or quartz that is precipitated between the sediment grains from calcium and silica bearing water respectively. Next, water. So chemical weathering is most intense in areas that have abundant water, where the water sources or water is abundantly available. Different minerals weather at different rates that are climate dependent. Ferromagnesian minerals break down quickly, whereas quartz is very resistant to weathering. Next come to oxygen. Oxygen is present in air and water and is an important part of many chemical reactions. One of the more common and visible chemical weathering reaction is the combination of iron and oxygen to form iron oxide. Next, acids. Acids are chemical compounds that decompose in water to release hydrogen atoms. Hydrogen atoms frequently substitute for other elements in mineral structures, breaking them down to form new minerals that contain the hydrogen atoms. The most abundant natural acid is carbonic acid, a weak acid that consists of dissolved carbon dioxide in water. Other acids that can affect the formation of minerals in the near surface weathering environment are organic acids derived from plants and humus material. Carbonic acid is produced in rainwater by reaction of the water with carbon dioxide gas in the temperature. So here bicarbonate H2O plus CO2 plus H2CO3 leads to the H plus carbonic acid, that is HCO3. H plus is a small ion that can easily enter crystal structure, releasing the other ions into the water. Types of chemical weathering reactions. First one is hydrolysis. H plus or OH minus replaces an ion in the mineral. Example, orthoclase plus water leads to the formation of clay and quartz. Next, oxidation. Pyroxene by oxidation gives magnetite and quartz. Next one is dehydration. Removal of H2O or OH ion from a mineral goethite leads to hematite and water. Next one is biological weathering. So plant roots can extend it into fractures and grow, causing expansion of the fracture and eventually can break rock. So in biological weathering, the mainly weathering activity occur due to the plants and animals. So in this way, we can see the weathering process. Animals burrowing or moving through cracks can break rock. Plants can penetrate into the ground just a few meters, whereas microorganisms can penetrate to a greater than 10 to 25 meters. So next, weathering effect of civil engineering projects. So what are the effects? we'll see as follows. Most civil engineering works are located close to the surface where the ground mass is affected by the weathering. So normally most of the civil engineering works are located close to the surface. So where the ground mass is affected by the weathering. The rate of weathering depends on climatic condition, rock mass, the type of rock mass, that means mineral composition, strength of rock, presence of joints, faults, shear zones, and other discontinuities. The weathering process varies from rocks to rocks and place to place, hence, such rocks are placed need special attention and focus. Weathering happens over large amount of time and is usually a contributor to the structural failures. Weathering takes place in all environments, but it most extensive in hot, wet climates where it may be expected to extend to great depth. The weathering of soft rocks is one of the primary causes of slopes failure and shallow landslide in hilly areas during monsoon season. Due to continuous impact of weathering on building material, the rock blocks materials between the rock blocks and soil grains gradually weakens and affects the civil constructions or civil structures. Weathering in road projects can cause cracks in pavements or even more worsen allowing water into the pavement structure over time. Intense weathering in reinforced concrete can contribute to structural failure when reinforcement is exposed to the elements in unsealed cracks. Rocks containing joints and fractures should be investigated thoroughly for long-term use. By reducing the strength of the hard rock, like granite can be a lot softer than when exposed to weathering conditions. So, course outcome from this session is, in this session we have learned about weathering of rocks and the types, mechanical weathering, process of mechanical weathering, spheroidal weathering, chemical weathering, process of chemical weathering, and types of chemical weathering, biological weathering, and weathering effects of civil engineering projects. So some of the multiple choice questions from these sessions are as follows. Soil is composed of, options are given here, organic matter produced by organisms, fragments of bedrock, clay minerals formed by the chemical alteration of bedrock, and all of these. Second question, the rate of chemical weathering is increased by acids. The most common natural acid on the earth's surface is nitric acid, hydrochloric acid, carbonic acid, and sulfuric acid. Caves are most likely to form in which of the following rocks types? Limestone, granite, basalt, sandstone. Fourth question is mechanical weathering produces clay minerals, quartz, smaller particles, and calcium carbonate. When liquid water freezes, it does not change in volume. It expands by 5% in volume. It expands by 9% in volume. It decreases in volume. Sixth question, the movement of rock particle by ice, wind, water, or gravity is called weathering, erosion, deposition, none of these. The actions of animals most commonly can cause the type of weathering, known as mechanical weathering, chemical weathering, general weathering, electrical weathering. So this is about session number 4. Thank you.